Hello everyone, welcome to our today's workshop in DLA. We are going to have an overview of the program first of all, and then we are going to see how the program really works. So in that part, Francesc Saya is showing us the modeling process and the beam features of land design in the live demo. Just please feel free to ask us during the session in chat box if you have any question. And well, from time to time, we are going to answer your questions. Let's know what is land design. Land design is a professional landscape software with BIM technology. It lets us to produce 2D drawing, model your project in 3D. It automatically generates a list of plants and other materials, and there are several tools for animation and visualization of the project. There are two versions of the program. One is for AutoCAD and Civil 3D, and another version works on top of Rhino. It means that if you have any of these platforms, you will be able to work with land design. The program is used for landscape architecture, but in addition, it has a high capacity for green infrastructure projects, for civil engineering, for urban planning projects, and for environmental projects. You can easily model a forest with land design. Let's see its main features. Land design includes an extensive plant database with more than 8,000 plant species. The plant species have several display modes and the botanical information. Also, the plant database includes several filters that let us to select the adequate plant based on soil type, climate type, or different aesthetics parameters. There are different display modes. One is conceptual. You can shift from conceptual to detailed just by one click, or from detailed to realistic as well. You can shift between 2D and 3D at any moment of the design process, as you see here, just by one click. Also, inside of plant database, there is a plant editor that lets us to modify and customize the existing plant species. And in this way, if there is a plant species that does not exist in the plant database, you can produce it by yourself. There are several methods for inserting vegetation. You can insert it individually, of course. Also, you can insert it by drawing, moving the mouse on the screen. You can convert points into real 3D plants just by one click. You can convert blocks. If you have, for example, AutoCAD blocks, you can convert them to a 3D plant in land design. You can draw a row of plants. The row may be combined with different plant species, or a group of plants combined with different plant species as well. You can also insert shrubs per square meter or per linear meter. You can indicate the density. Or you can insert ground cover plants and indicate again the density. They have different representations, let's say. There's a topiary tool that lets us to cover any 3D shape easily by plants. In that way, if you have a 3D model, you can cover it with a list of specific adequate plants for topiary. Land design provides you that list, and finally you cover your area, whatever shape they have, and finally produce the topiary in this way. For terrain modeling tools, there are powerful tools that let you to convert points, lines, or combination of points and lines into the terrain. Once the terrain is generated, you can easily modify it with control points. You can create a path for different cotton fields on top of this terrain. Land design will calculate the volume of earth moving operation automatically. You can divide the terrain in different parts, as you see here. You can assign different material to each part of the terrain, etc. Also, you can import terrain from the web just by looking for the location of the project on the map. you can insert the 3D terrain of that selected area. Landsdesign uses a global elevation database for inserting that, for that elevation information and inserting that piece of terrain. The precision in this way is 1 sample each 30 meters, so it's useful for medium to large scale projects. In addition, you can insert the 3D mesh of the selected area, including the satellite image. You can convert the imported terrain, see that in 2D, and see all topographic contours that contains that selected area. In addition, you can import 3D buildings. In this example, we are going to import Central Park of New York. As you see, you can select that in addition to the terrain, you also want to have the existing 3D buildings in the project. In this way, as you see, we got Central Park and all its surroundings. There are tools, dynamic documentation tools that let us to produce the list of plants, earth moving operation, furniture, zoning, etc. just by one click. You can also add the image of plant, add labels, and produce different types of documentation, different plans, and whatever you need for delivery. There are parametric hardscape tools, including parametric walls and curves, parametric paths, parametric fences, and they are customizable. And there's a block library for furniture inside the program. There are tools for irrigation system. You can design the irrigation system, and landsdesign will calculate the volume of pipes, sprinklers, and emitters that you have used during the design process. For visualization, there are several modes. There are several tools. There's VAC mode, visual simulation. There are sun and shadow tools. There are render possibilities with different compatible renders, and there's an image filter inside the program. The animation that you see here is a project modeled with landsdesign, and the animation is made with Enscape in this example. But there are several renders that are compatible, including Twinmotion, V-Ray, Lumion, and Enscape. You have heard about parametric architecture and parametric design for sure. This kind of algorithmic designs that we use algorithms to have this kind of different relationship between landscape elements. Now it's possible in landsdesign. We have grasshopper components, and well, just let's see a simple example of what we can do. We are going just to populate this area with plants. The height of plants be dependent to their distance to the axis of the path. So you can do everything automatically. And then if we move the path, everything changes automatically. So you see that all plants, all the trees will have the same algorithm during the process. There are unlimited possibilities that you can achieve with the help of Grasshopper. You can link different hardscape and softscape together, different parameters to be dependent to each other, and we will see that later on during the live demo. Now we have the possibility to link landscape project that is made with landsdesign inside Revit. As you see, you can open the project inside Revit, and if you do any kind of modification on vegetation or on terrain, you will see all modifications in Revit at the same time. So it's quite good news for those who were looking for a landscape design solution for Revit. So let's see how is the design process with landsdesign in general. You can import the terrain as we saw before, or convert topographic contours into the terrain. There's a nice tool for elevating these contours, and once you have elevated them, you can convert it into the terrain. Also, you have the possibility to create a terrain by point clouds or DEM files. Well, after creating the terrain, you can zonify the project in different zones. It gives you the area of each zone. You can assign material and label to each zone. In continue, you can continue with inserting plants, for example. individually or in a row or in a forest mode. Once you insert the plants, also you can decide to have natural variation. For example, if you want to have plants with different height and different size, this is something that is quite possible. Well, just in continue, you can add hardscape tools, walls, curbs, fences into the project. You can add blocks to the project. As I said, there's a block library inside the program, but in addition, there are unlimited possibilities that you can import from the web, all blocks that are compatible, especially in Rhino version, there are more than 54 file formats that are compatible, and you can open those blocks inside landsdesign. You can shift between 2D and 3D at any moment of the project. As you see here, you can do modification in 2D and see what is happening in 3D. Finally, you insert the list of plants, furniture, earth moving operation, and so on. And you finally render the project. Okay, so this is the design workflow with landsdesign. Basically, you start with AutoCAD, Rhino, or Civil 3D. In continue, you model the project with landsdesign. Also, you can import geographic tools, GIS files, or DEM files, or point clouds into landsdesign. Landsdesign can create a terrain with these point clouds. Sorry. In continue, for visualization, you can apply a render that is compatible. For example, as I said, Inkscape, V-Ray, or Twinmotion, or Lumion. You can have virtual reality, so with headsets, you can walk through the project and live in virtual reality. You can print your project with a 3D printer. You can export your documentation to export or PDF, for example, or print your drawings easily. At any moment of the design process, you may have collaboration with other BIM and 3D tools like SketchUp, Revit, or 3D Max. You can import or export model from these programs or to these programs. So these are some examples of the projects that are realized with landsdesign. And the project in Egypt that landsdesign is used for. Landsdesign is used as a complement of an architectural project, or this one is a Canadian project that landsdesign is used for all landscape design process. So in summary, landsdesign is available for Rhino, AutoCAD, and Civil 3D. There are 90-day free trial. The licenses are permanent. You will have free technical support all the time. There are educational licenses and lab licenses for the schools that includes 30 users at a quite reduced price. And the development has been based on our users' feedback, so we will appreciate any kind of feedback or suggestions that we receive from our users to improve the program. Well, if you have any questions, just feel free to write us later on to landsdesign@asuni.com. Up to now, is there any question? Well, I'm going to leave this part. Francisca will continue with the live demo and will show us how a 3D landscape can be developed with landsdesign.
All right, thank you very much, Elham. So basically, we're going to see now what we have seen in this nice presentation, but through a live demo. Okay, we will continue developing this small garden that we've got here, and we will fill it with some vegetation and some landscape elements. First of all, I would like to introduce the main the landsdesign toolbar. So we've got basically here the commands to insert vegetation elements. Okay, we can insert plants individually, as we have seen, arranged in rows, in forests, shrubs, ground covers. Also, wrap any piece of geometry with this topiary command. We've got also a few civil work commands to insert walls, fences, stairs, paths, or rows of elements that we can browse from the library. Here we can find all the commands related to terrains. Okay, we can generate terrains from points or from curves or a mixture of them. We can apply some earth movement operations. Also, we can import from the web, as we have seen, or we can elevate curves. So on those, we can create terrains. We've got here some documentation tools for irrigation commands. We can insert the sprinklers, also arranged in an array, pipes, which are basically 2D elements with data about pressure and type. We've got here the listing commands. Okay, these are all elements that we can list with landsdesign, and of course export those lists to Excel. We've got some tagging commands, labels, pictures of the species, dimensions, slopes, and areas. We have also a command to drop some shadows for the 2D, for nice 2D drawings of the setting out plan. Finally, we've got some additional commands. For example, this first one opens this edit panel, which is already open. From here, we will be able to edit every object that we select in the scene. But also, we've got here the animation panel. I can just open it to have it ready when we explain how to produce some nice animations. And then some other commands, for example, to open the plan database, this image filter application built in landsdesign, or command to set viewpoints, or navigate through the project with the walk mode. Okay. So let's take a look at the edit panel. And because when nothing is selected, we can see here from the top left corner of this dialog, the list of all the species and urban furniture and other elements, if there were more, that are currently in the scene. So we can select all the species, or we can select them by name. All right. Also from here, we can just double click to hide them eventually. All right. And when we select some species, we can edit their representation type. So we've got two options for plan for the crown, setting out symbol and a more developed to the crown. But also we've got different representation modes in elevation, conceptual, detailed, and realistic. Okay. Actually, when nothing is selected, we can switch from these different display types, okay, from these options over here. We can go from elevations to conceptual, detailed, and finally realistic. So depending on the level of detail we want to show the scene, we may use one or another. So it's more convenient for different levels of detail. But actually, this realistic one is the representation which integrates all the textures into the geometry, and this realistic representation can handle different appearances according to seasons. So if we scroll this down, we can switch from one season to another, and some of these plants, if they have another appearance assigned to that different season, it will switch to that different representation. All right, so I'm gonna move this back to spring. Also, well, when we select this realistic representation, we can switch to billboard. So we have a very simple representation, and this will let us handle a large model with a big number of elements, okay, and still work with a smooth workflow, okay. But well, since it's a small project, I'm gonna select the 3D. By the way, this is going to be improved in following versions, so we'll have a better representation of objects, an optimized way of showing plants according to the distance, and we'll, in order to increase the performance. Okay. All right. So in addition to the 3D representation, we can show the objects, the land elements in a 2D plan view representation. When we select this 2D icon over here, all the elements will show, well, the 2D ground in the case of the plants, but also a hatch pattern in the case of zones, some contour lines in the case of terrains, we'll see later on, and so on. Okay, so lands elements have this double representation in 3D and in plan view. So we can keep on working in 2D if you are more familiar to working in 2D, for example, but at any time we can switch to the 3D model, okay, and all objects will be displayed that way. Okay. Also, this document is geolocalized. Okay, this is taking the geolocation based on Rhino document. Of course, we can change that. And well, from the edit panel, you just manage all this document parameters. Okay. Also, you can define in which layer the new objects are located when you create them. Okay. This is something that you can customize in your templates. So this is ready to. This is prepared when you set a new document. You have all the elements located in a specific layer, so it's easier later on to select all the zones from the corresponding layer or all the planting from another layer. Okay. All right. So one of the first steps in the design process is basically define the areas, so you can have an idea about the square meters that you are using for one purpose or another. So let's insert a zone here, and we can see how it works. We're going to use this zonify command, and basically we can insert the zone by picking an existing closed curve, or by picking an empty area, an empty area that will find the boundary elements. Okay, so when we run this command, we can just pick an inner point, or in this case, I'm going to select this boundaries option in the command line, select this curve. So we'll need to define a name for that zone and well, a hatch pattern for the 2D representation of the zone, or also a material for the 3D representation. Actually, here we can browse for the well, textures available in landsdesign library, materials library. So we can select any of these textures. Okay. All right. So, well, we've got all the zones created. Here we could already insert a list of zones. We already have an idea about total square meters that we are using for this project. So here under the documentation toolbar, we can find the zoning list. So we can have an idea about this, well, the total square meters. And of course, this is a list that if we select it from the edit panel, we can well, enable a few more fields, okay, such as the icons. And well, this is a list that updates with any change on the zones in the 3D model. Okay. Right. Let's insert a few plans here, so we see how is the basic workflow inserting visualization elements. I'm gonna insert an individual plan right now. So of course, this is an existing document that already has some species here, so we can see the species that we have already used in this document, but we can browse for the plant database for a new species. Well, here we can see all these filters. We can find specific species by all these characteristics. Okay, we can select some criteria, and this list will filter those species that match with those with this criteria. Okay, or we can just type here the desired species. When we navigate through this list, this right side of the dialog will update with the well, the realistic representation and conceptual detail and a few pictures loaded from the cloud. Actually, we can load them from here as well. Find more. There are a few images stored into the program, but we can also activate this to find for more pictures. But like, for example, let's find here some lemon tree. So this would be the citrus lemon species. And maybe we can take a look at its properties. If we click on this button, because we can edit any species and change any detail that we want. Okay? For example, we can go to the display tab, and here we can change the 2D ground that this species is using. We assign a different block, so we can explore the different 2D grounds available for the 2D representation or planting. Okay. Of course, these are just blocks stored in that folder. So if you have your own one, of course, you can add it to that folder and have it available for the 2D representation of your plant. Okay. You can do this with the 3D conceptual shape, with the detailed shape. There are a few blocks available, and also with the render. So if we explore, the folder where all these NXT plants are stored, basically there are two file formats for realistic representation. They are created with two different plant editors, and one of them is integrated into landsdesign, so we'll be able to create new of these realistic plant files. So yeah, we can explore over 600 different files, and well, take the most similar one and from the plant editor, adjust it to the real appearance of the plant if the chosen one is not really accurate. But anyway, from this plant editor, we can launch one of these editors, and here we'll see, all the parameters to play with. So we find the desired appearance for our species. Because right now we are editing an existing species, but we can create totally new species from scratch or by duplicating an existing one. So we can launch this editor to generate new of these other plant X files for new, for the new species. Okay? We can assign some textures here, some foliage, fruits. We can save different settings according to definitions, and we're going to assign its definition to a specific season. That means that's how we can render the same plant one way or another, depending on the season we set into our document. Okay, I'm going to close this right now. I'm just interested to insert that lemon tree. Here we define the head. And well, this natural variation and random rotation is recommendable to have it enabled, because if we insert several units, each one will be a little bit rotated from another one, and will have a slightly difference in head. So each one will look like a different tree, even though they are using the same block. Okay. All right. So we just need to insert the plant. And once it is there, we can select it and edit the same parameters from the lands edit panel. We can change the species here. We can change the head, right? And well, actually, we can also override the season, the document season by species, by item. So this is something that we can also do. And check this. All right. So before we insert a few more species with the forest command or the ground cover, let's talk about a little bit terrains. By the way, feel free to ask any questions, otherwise I'll just go on, okay? But it will be interesting, to maybe to focus on any feature that we are seeing that might be more interesting for you to discuss more in detail. So feel free to raise your hand and ask any question. So before we take a look at the terrain modeling tools, let's mention that any piece of geometry, such as this surface, this is just a Rhino surface that has its control points. This object and any Rhino object can be tagged as a terrain. And when we do so, all the objects can be projected on top of it. It will be easier to take this object as a terrain. So any element will be located in the corresponding position. So we need to select that object, and from the edit panel, we can see this tag as terrain option. And once this has been tagged as a terrain, we can make copies of this tree, for example. Okay, so when we release the mouse, okay, if the tree, maybe I didn't tag this as a terrain. All right, yeah, I didn't do it properly before. So as you can see, as soon as I tag this as a terrain, the plants detect this object as a terrain and just go up to the right elevation. Now we can move this around, okay, and they will find the desired or the proper elevation of the terrain. But of course, this is just a Rhino surface still, and we cannot apply all these terrain operations with that surface. So in order to work with true terrain, we'll need to create it. And this is done from curves or from points, as I was mentioning. So I'm going to delete this surface. Now, well, I have already some, some contour lines here. This could be a very typical situation where you want to create terrain and you just get as input information all the contour lines, but in a flat elevation. And then we can imagine this situation where we need to elevate these curves according to an interval in order to later on create a terrain out of them. So as I was mentioning before, we've got this elevate curves command. So we need to draw a line that intersects with these curves that we want to elevate. And then we need to define here the increment and apply changes. If you see that this is maybe too much, let's say that 1 meter, for example, I'll apply this again. Okay. So we've got now these curves in the desired elevation. So we are ready to run the terrain command now. So we run it. We can use DLA triangulation, a pure DLA triangulation based on the the control points of these curves that we'll use as an input data for the terrain, or we can actually use this grid surface shape triangulation that will let us have control of the cell size and therefore generate a terrain more or less accurate according to this input data, okay, the initial contours. We can also define a base. Click OK, and I will finally need to select this contour. Okay, here we are. Actually, now we don't need these contours anymore. We could delete them. Actually, we have them in a specific layer, so I'm going to just hide it. But if we select the terrain, we will notice that this terrain has absorbed the control points of this curve. That means that we can select them, and we can still modify the terrain, as if we were modifying the original curve. Okay, so we can edit the terrain based on these control points that has inherited from this curve. Well, I can see there is a gap here that I don't like, of course. Of course, maybe I needed to take this curve into account when I created the terrain, but rather than repeating the process again, we can add this contour curve into the list of curves that were used for generating the terrain. So one of these commands over here is the option to add a contour. So I'm going to select the terrain. Now I will select this curve over here and kind of hit enter. So the terrain will be adjusted to also integrate this curve into its input data. And actually, this can be checked here under the landsdesign panel. Here we can find all the terrain parameters. So we can change the cell size if you want. And under the input data, we can see here all the list of curves. Okay. And actually, we can disable the control points of each one of them if we don't want to see them at all. Okay. and or we can select one of them and remove it. So the terrain will be recalculated with the remaining curves. So any operation that we apply in this terrain will be listed under this input data tab into this section. By the way, if we show now the project in 2D, we'll see these control curves. And select the hide the grid. And actually, maybe it's worth it here to show the terrain in 3D and 2D at the same time. So there is a specific option for lands elements to display both 2D and 3D representation. And for the terrains, it's quite useful because it gives a better feedback of the terrain topography, right? And now, well, we can check also the contour lines feature. And here we can see that, well, we have a total number of contours right now, but maybe it's more convenient to set the distance between contours. So let's say that we want contours every 20 centimeters, since it's a small terrain. And also that's an interesting option if we want to have a better, representation of contour curves every certain number of contours. We can change the attributes every certain number of contours. All right. So about this terrain, let's apply some operations so we can see how this works. For example, I've got this curve over here, and I'm going to use it to add a path on this terrain. So it's important to mention that I've got already this curve elevated into the proper elevation, right? So basically, the terrain will adapt to the position of this curve to produce here some land movement to add a path. So of course, then the position of this curve will matter because the terrain will just try to fit into it. Okay, taking this into account, you have this curve synced here, or maybe floating. So the terrain will be adapted to fit its position. Now we can find here the add path command. Okay, so we will select the terrain, define the width, for example, 2 meters, and an angle, basically how the terrain will modify along its path to meet the existing terrain. So 45 degrees, it's fine. And finally, you just need to select that curve. So you can see here, for the path added to terrain, and maybe we'll be able to appreciate it better if, once we select the terrain, we can see here a subdivision, and now we can assign a different texture for that area. If you're using V-Ray or another render plugin for Rhino, then you can pick any of these materials. Okay. Otherwise, you can just select any of those that are provided by landsdesign. All right, and well, in a similar way, if we want to flatten some area over here, we can draw, for example, the boundary of this area. Let me show this in ghosted so you can see where my rectangle is, and I'm going to elevate it a little bit so we've got part of it inside the terrain and part of it outside. So of course this will force the move this tree. When we add the cut and fill here, of course, some part of the terrain will be removed, and then we will need some other part to fill, to flatten this area around this boundary. Okay. I'm gonna switch back to render, which is nicer, of course. And here we've got this cut and fill command. So we pick the terrain. Again, we need to define an angle, for the slope around this boundary curve. And finally, select the close curve. All right, and it generates this flatten area. By the way, this curve, use it for the terrain, could be also a slanted curve. So we could have a curve like this, and then the terrain will fit, with this plane. So this could be used for specific slopes on the terrain controlled by this one. Okay. Great. We will keep this curve, but just keep in mind that now when we select the terrain, the curves of the path on one hand and this boundary on the other hand have been integrated into the terrain. So we can maybe select this, this boundary and move it to another position, or we can select this corner and also modify, the contour of the terrain based on the contour field based on these control points. All right, and well, since we have inserted, a terrain and we have applied a few modifications, we can list all this information here under the terrain list, a command. So we will see on one hand the area of the path operation and the area of the cutoff field and the amount of volume that has been added or removed from the original terrain. All right, so let's go on. I'm gonna insert a few more plants, and I'm gonna show it how to do it with the forest command. So when we run the forest command, we need to select again some species. I'm gonna select one of those that we have used before. Some height. Here it makes even more sense, to select this natural variation. So all the elements in that forest don't look exactly the same height, and also the random rotation. And under the forest tab, I'm going to choose here the way we want to arrange it. For example, we can select random distribution according to a total number of units, maybe insert a few less number of species, and we can control also the distance between each meters. Would be more convenient. And finally, we can either select an existing contour, okay, or we can draw it on the fly. So I'm going to draw it from the top viewport, and I'm going to use any of these options available here. So maybe polyline, and you will see that as I am defining this contour of the forest, the elements are already inserted. I don't really need, to close this. I mean, when I do right click, this boundary closes automatically, and I can find all the elements already projected on top of this terrain. Well, this is completely random distribution. If you don't like it, you can select the forest, and under the properties of the forest, you can redistribute it as many times as you wish. Okay. We can add a hole. For example, if we had a kind of a path passing through this forest, we could select this boundary, and the area will clear the trees that are inside, and they will be redistributed in order to keep this path clear. Okay, so we can have some holes to still keep the whole region for the forest, but clearing some areas inside it. Well, we can also see how this looks like when we choose the array option. Okay. We have different spacing distributions here. We can also combine species. I mean, here we can see that we are using only one element. If we choose to, then from this area of the edit panel, we will be able to select two groups of species, and maybe we can change the species of one or another. We can do some combination of species within the same forest. And this is an option also available in plant rows. We haven't seen that, but in a similar way, we can draw row of plants, and these also have different parameters to distribute them according to separation, total number of units, and we can also combine elements in plant rows. Now, let's insert for ground cover here. So I'm going to use this ground cover command. Ground covers filters the species that are available according to those that have a specific representation type. They are also generated with the plant editor, but the file format is a bit different, and the way that 3D representation is generated is also a bit different. So we can select any of these species. Okay, density, plant scale. Also, ground covers are represented with a 2D hatch pattern in 2D. And now I can just draw, the boundary curve, or since I've got here an existing one, I'm going to select it. Okay. But of course, if we select now this boundary of the ground cover, this will adapt with the terrain, topography. Well, there is another option for using the ground covers on vertical planes for simulating vertical gardens. Okay? And actually, we can also use the forest command for that. The only thing we need to take into account is to choose a curve that is already in a vertical plane, such as this one. So in this case, I'm going to show it how it works with the ground cover. So I'm just going to select that same species as before, click OK, and then when I select this vertical curve, the ground cover will fill all this area. Take into account that there are some species as well that they have a specific representation for vertical gardens. If you explore the plant database, here we've got some groups of plant species, okay, according to those that you can add as favorite if you double click on this heart icon, or those that come with picture, or those that come with a specific render file. If there are over 8,000 species in the plant database, but not all 8,000 have their own realistic representation. Okay? Most of them, they use the most similar one. But here we can filter those that already have specific representation built in for that particular species. And one of these groups is those species that are suitable for vertical gardens. Okay. And then they have a specific representation that simulates also gravity and this fall down feeling. Okay. All right. Do you have any questions so far?
Not so far.
All right. Also, if you're shy to talk, you can also type in the chat box, okay? And Aham will answer, or we can discuss it. Everyone, if it's worth it. Okay, let's go on with some of these civil work elements. For example, we can see how to insert a wall. Basically, a wall is a parametric object defined by a thickness, a height, and some alignment and justification. And now we can draw, for example, a wall following this contour using this polyline option in the command. Enable the osnaps. I've got the justification to left, so I'm just gonna osnap that corner. Okay, just notice that I've got this wall just being adjusted to the terrain because I've got this icon enabled. Actually, I didn't mention that before, but whenever we've got this button enabled, any element that we draw on top of the terrain boundary will be projected on top of it. While if this is disabled, the objects will be located in the corresponding the current construction plane. So in that case, we don't want that this piece of wall goes over the terrain, so we can just select it and tell it to do not be adjusted to the terrain. It will put it down to the zero elevation. In that case, where it is where we have the construction point. Also, we would like to make one wall similar to another, same height, the same alignment, the same material. Actually, here we've got also a library of materials for walls. And there is a quick option here in the edit panel to copy properties from another object. So if we select that wall, this will take the same attributes. Okay, same height, same alignment, same material. That's kind of handy tool. Now, let's insert a row of elements. Maybe we can create here a row of street lights along this path. And I'm gonna use this curve as the path for the row. Okay. So I'm gonna run this row command. We have the option to pick any piece of geometry in the model, okay, or browse for any file that we've got in our computer, or we can browse in the block library that provides landsdesign. Here you can explore different blocks, okay, that are available. You can see here many urban furniture. We've got people, we have planters, we have stones. All right, so you can explore these objects. And of course, if you have your own library of 3D blocks, you can add it to this list. Basically, you can, this is nothing but, you know, a shortcut to a specific folder in your machine, so you can add here your own folder location to have it available and browse your own blocks. Well, keep in mind that Rhino has a wide range of file format support. So probably any 3D model out there can be opened with Rhino. Well, I'm gonna pick one of these lighting, okay. And well, we've got different orientation options here that choose this perpendicular to axis. And here on the row, we're gonna define, yeah, that could define separation of 8 meters. And I will select now this curve. Okay. Actually, I didn't mention that we can see that if we select the row now, that it had already a distance to axis. Of course, if this was 0, you know, we will have the objects exactly in the same position where my curve is, but this is not. That's not the design option here. And maybe we can change the orientation of these objects if we invert it from here, and they will look one direction or another, or if we set it to tangent, we'll finally, and I check this invert option, we'll finally get the desired orientation. Okay. But of course, you can control the separation, so more items are added here, or we can define total number of elements, okay, in that row. Okay, so let's talk about a bit of lines documentation. Let's imagine that we've got our project ready, and we just need to well, list all the elements that we've got. So we have inserted a zoning list and also a terrain list. Now we can insert a plant list. So here it is. And of course, we can see the total number of units for each species here. And well, this just to ensure that this displays what's happening here, if we edit, for example, the number of elements in this forest, I'm going to change the array. Okay. As you can see here, the number of Cedrus, Atlantica, and Acer has changed as soon as I edit the number of species in the 3D model. So it's a live list, and we'll always update with the information on the field in the 3D model. If we select the list, we can also see here the different fields that we can display. Maybe it's worth it to enable this density, okay. Because we've got some This is used for ground covers. And well, in addition to this list, we can add new parameters. And this is something that is available from the document properties. If you go to Rhino option, we go to document properties, parameters, and here we can add new parameters that later on will be we can display in tables and of course feed launch elements with values. For example, let's imagine that we want to also list the price of each item in the scene. We can assign it to a category, general, and the data type could be points. So we can add as many parameters as we want. And now when we select an object, for example, this lemon tree, under the properties, we'll find this parameter section. And here we can add a value for the price. Imagine that this is 1,000 and this other lemon tree is 800. Now, when we select that list and edit it, we will see now this new parameter in that field, list of fields. So we can enable the price. And of course, for the lemon tree, we'll see 3 units with a corresponding value for the price. Okay. All right. And well, just to mention that if we select this list, we go here, we can export it, or we can export that as a HTML file, but also XLS to open it in Excel. Yeah. All right. So let's see some other features for 2D documentation. Maybe we can measure the slope on this terrain using this slope tool. Basically, this well calculates the slope between 2 points, okay, from the start and end point that are projected on top of the terrain, and thus the slope is calculated. So I can draw a polyline and say I want to measure the slope from that point to that other one. Okay, get here the result, or I can select that curve and see the slope of that path. Okay. Of course, this slope doesn't take into account that the hills that are in between, so it just measures the start and end points, okay, that are projected on the terrain. Okay, well, here we've got the plant shadows that I was mentioning before. So this generates these hatches at the bottom of the plant. And if we select them, we can change the height, okay, or the direction to simulate one specific hour in the day. Also, we can change that for another hatch pattern. Okay, maybe this too. And get this nice hatch pattern for the shadow, plant shadow. By the way, this direction doesn't follow the real shadows according to the north of this document. This is something that we can also enable with the sand tool of Rhino. You know that we've got this sand panel here. That's basically a Rhino feature. And when we enable it, of course, if we are using in that display mode the scene lighting, and we'll be able to see the shadows according to one moment of the year and 1 hour of the day. So we can play this, with this slider, a simulation of how the shadows will more or less perform during the day on that site. All right, maybe it's moment to to play an animation. So I'm gonna move to the land animation panel, and notice here that we've got this camera, and we need to define a path. So actually, I've got a specific layer with a curve that I'm going to use for the camera path. It's this one. And well, from here I need to click on this button to select the path curve. Actually, now we can already hide it. So it's already linked with this path. So it's when we play the animation, we are not going to see it. And we can define the frames per second or the total duration of this animation. Now, well, here we have some options for the camera. We've got the option to just show a preview of this animation with the play button. Okay. We can see how this this virtual tour will look like. And we also have the option to save that animation as an AVI file. And we can choose either the Rhino display, which is what we are using now, or we can use the Rhino render or the current renderer that you've got in that moment. Of course, I'm not going to do this now because it will take some time for each frame, and we'll take some time to produce the final video. But that's how you would produce animations in Rhino with these tools. And actually, when you choose the Rhino render or the render option, you can also enable these options. This is a season change simulation. So the plants will be rendered at the beginning of the animation in one way and at the end of the animation in another way. Okay, we can also enable a plant growth and some wind effect. But again, these effects are only visible when we use a Rhino render option. Okay, not the display, but the render. All right, and finally, maybe we can see when we activate the wall mode how this looks like. Basically, this puts us onto the ground, and with the mouse cursors, we can just go left and right and navigate through the project interactively. Okay. The terrain is detected, so you just climb automatically on top of it. And with the mouse pointer, we can just look toward one position or another. And with the escape command, we will just quit this walk mode. All right. Any questions so far?
Not actually. It's just one question about the parametric features of fences.
All right,
If they are parametric or no. Yeah.
Yeah, maybe we can take a quick look of fences as well. Maybe draw a fence here. So basically, fences are objects generated with posts and balusters, and also sashes, okay, or rails that are parametric. So we can browse in the block library for one specific block for the baluster. There are a few of them actually, but you can pick any 3D element in the model. And well, when you have selected your elements, you can just draw a polyline and draw your fence here. Okay. So the interesting part of these elements that we can take any piece of geometry. Maybe we can have a kind of tapered, tapered column here, and we could select this fence, and here from the post, I can select this item here to replace the post. So you can customize pretty much the appearance of this fence in a parametric way with all these options. Okay. We can do the same with the baluster, and here they are all the different options for these rails. Okay, we can change the profile, or we can just disable it and explore all these features to control the way this fence will look like. Okay. All right, so now I would like to follow with some examples of the integration of land design with Grasshopper. Actually, this will let us also connect landsdesign with Revit through the Rhino side technology. I would like to ask you if you know already Grasshopper, or if you don't, in order to to be more gentle in a way to introduce this integration to you. So please feel free to let us know your feedback about in the chat box if you know Grasshopper. Well, in case you don't know about it, well, I'm gonna open it from here. Basically, Grasshopper is a tool integrated into Rhino that lets us do some visual programming, okay, through well, components that could be numeric elements, could be geometry, could be operations, and it's a way to program, but in a visual and intuitive way. Okay. So basically, with Grasshopper, you have control of automating many tasks and iterating through different design possibilities, and most of all, be your own creator of parametric design, okay, which can well, improve all the design modeling processes and also the way of managing data and geometry. So, okay, we've got all the lands components available in Grasshopper. That means that, for example, if we want to insert here some plants, we can maybe draw an array of plants based on some grid components. We've got this radial. Okay, the plane will be maybe this plane that I draw here. Maybe I'm gonna just reference one point in the middle, and I will use this point as my insert point. Okay. Now I've got this, this radial grid that let me control the cell size from number that goes from 1 to 10. And so we'll be able to change, this well, size. And we can also use this numeric value to control the extent in one direction and the extent in the other direction. So we have a parametric grid, and this gives as a result cells and points. So we can use these points to generate plants. We go to the lands components. You can find here the plant component, and we will indicate that the position of these plants are these points that come out from this radial cell. Of course, now we can keep on, changing the parameters of this grid and work in a parametric way. Of course, this has inserted a generic plant with specific height. If we want to control, to change that, we have the plant options. And now with another numeric slider that maybe goes from 1 meter to maybe 30 meters, we will be able to change the height of these plants. Well, if you will see that the height doesn't change, probably we're using a species that has a maximum height. You can just do right click here to set a different species. I'll select that ISO. And now this is a bigger plant, so we'll be able to change the height here. And well, what we see here is actually a preview of what's happening in Grasshopper. We cannot select the plants here, but we can just bake this component where all these plants come out. And when I do that, I will get plants in my model. Okay. Well, you see here a little bit the value of plants. I'm gonna delete these shadows. Maybe I can show another example. Delete the plants here in the middle. which is another example that rather than creating new plans, we're gonna use reference plans to create new stuff. I'm gonna open the document. Okay, like this. So basically, this is a definition that we can reference some plans. If you right click, set multiple plans, maybe we can already select these plans. And this, well, detects the position of these plans, okay, the bottom insert point. It also can read the height of the plans. We've got these deconstruct plot options that based on some reference plans, we can read the heads of these plans. And just by drawing some circles and making some unions of the regions generated at the bottom, we can create these kind of pods. And the diameter of these pods are based on the plant's head. Okay? And of course, if I move the position of these plants, all these pods will update with a new position. And of course, if I select any of this plant and change the head, I will be able to see also how the diameter changes. Okay, so basically you define, how you want to create stuff, how what rules you want to and constraint you want to apply in your designs, and from that point do unlimited options design and design possibilities. Now I would like to show you some, just to finish, some example of how we can use these components also to send this model to Revit. Actually, I'm going to save this. I'm going to save it as DLA 2022. I'm going to put this into the desktop. And, well, in the meantime, I'm going to open Revit. And here, as you may know, if we've got the Run Inside plugin installed, Run Inside is a plugin that lets you run Rhino as a plugin of programs, for example, Revit. So here I already installed the Run Inside plugin for Revit. And when you do so, we've got this, this toolbar. I mean, first you see some start button here, okay, which enables all these buttons. And now I am able to launch Rhino running as a plugin of Revit. Okay. And what I'm going to do now is to open that file that we have just saved. This one. I would say open. And we'll see how we can transfer the geometry from that model so it's generated live in Revit. We have different ways to do that, but just the idea is that we will use the Revit and Lance components in Grasshopper to do this conversion. So I'm going to show how to do this with the terrain as example. So when we're in Revit and we launch also Grasshopper, we will find some Revit aware components in Grasshopper. And for example, we can use also the Lance component to reference the terrain. I'm going to use this Lance pipeline. I'm going to double click on this terrain icon so the terrain is referenced. And since the terrain is basically a mesh, so we can deconstruct that terrain. But basically, we can explore it. So we obtain each one of the mesh divisions for this terrain. So I'm gonna, out of this list of divisions, I'm gonna select the one on the top. Okay. And I will just use this resulting mesh to create a Revit topography. Okay, we've got this a topography as a mesh. And what I will get as a result is the terrain already created in Revit. Okay, this is a live connection with Revit. So any change I do now on my Rhino model, for example, we can quickly raise this this control point. So we've got a steep terrain on that corner. If we go back to Revit, we'll see this change line. Okay. Of course, there is here some missing mesh for the divisions, but this is just a matter, to generate new areas according to the division meshes that are as a result. And if we select this object in Revit, we can see this is a topography. So with this integration, we can basically have landsdesign as a terrain modeler for Revit. Okay. Well, another option to show this integration is by, well, there is a definition in Food for Rhino, okay, that is already prepared definition to bring different lands elements from Rhino to Revit. Basically, when you download this, you will get a folder with different Grasshopper files. And we can have these files as buttons in Revit ribbon to bring the geometry from that model to Revit. So I'm going to show how to do this. And basically, from Revit, we need to go to the Get More button. We go to Options. And under the scripts, I'm going to add script location. So I've got this in the desktop. Okay, so this is the folder where I have stored all these files downloaded from Grasshopper. When I click OK, I will get all these buttons that are used to import into Revit the elements, the lands elements that are referenced in Rhino. So I have already the Rhino model open, and now we can insert, for example, the fences. I run this button. Okay, maybe fences are not referenced. Maybe it takes a second. Maybe we can try with the plants. Yeah, depending on the amount of elements, this may take more or less. Also, the species that we are using that may have more level of detail or less level of detail may take longer time to show up here in Revit when we do the conversion. Basically, we're deconstructing all the plant meshes and importing them into Revit. So here it is. All the plants that we are generating right now they will appear here. Okay. So we can do this with the furniture elements. For the fences didn't work, so it's something that we should check it out in that definition. Maybe in the furniture we may see the row, the row of items, and do this for the rest of the elements. Okay. We can import the zones and import all the elements. And of course, if we do any change on the 3D model, we want to update this. Maybe I just want to delete all these plans. Okay, we can just go back to Revit and I'm going to run the plans button again, and this will recalculate it. Updating the document with existing situation in our Rhino model. So while this is updating, do you have any questions? Something that you would like to ask?
Well,
no questions.
Not so far. Let's take a look at our project gallery. And
Okay.
well, the lab license maybe would be interesting for those teachers and lecturers. to know a little bit more about. So let's take a look at our website.
Yeah, here you can explore different projects created with land design. And well, some of them integrate, they are done with these amazing render tools such as Enscape or Lumion or Twinmotion. Well, you can explore the different results or maybe render it directly from Rhino.
Actually, regarding the workflow with Revit, we know that there are many architectural firms that are interested in some solution for their landscape field. So we would be happy to hear about you if you have any experience or you will have any experience. Just feel free to try it out, the 90-day free trial of the program, and let us know how is your experience with land design inside Revit. That would be great to hear about it.
There is a question by Chris. I can see that he's asking,
Yeah.
Working with the link to Revit, how do wall steps work? Well, in the case of land elements, I work completely in Revit, so happy to test that. Yeah, great. You can, I mean, we are transferring here land elements. So we can transfer walls as well. But of course, walls in lands are very simple. You know, they're just parametric objects defined by thickness and a height. And well, if you want more different shape, if you have any 3D geometry in Rhino, you can also transfer that as a direct shape to Revit and tag it with a specific type according to Revit. Okay, so you can type any direct shape as a wall. Okay, or you can extract the path curve of that object and have it as that wall path in Revit. In that case, so land design can identify the path curve of this wall, the height and the thickness, and generate a geometry that is transferred into Revit as a wall.
Another feature that maybe we must mention before is that now we also have the possibility to export land design project into IFC. So in that way, you will be able to open it in other software, not just Revit, maybe AutoCAD as well.
That's right. I can see that all these plans that I deleted before didn't update, so it's something that we will revise as well.
Well, there's another question from Chris. Does it work the other way? So if I update, you mean updating the definition, you mean? Yes. Yes, whatever modification that you do in Rhino, later you update the definition, just click on the definition on top of a Revit environment, and all the model will be updated in Revit too.
Yeah, that's what we did with the terrain.
Yeah.
Okay.
Yeah. And there's another question, can I use land design files export into InMotion as well? Yes, of course. There are two ways to export into InMotion, the direct link and data speed, and well, both are already working with land design. Any other question? Just open your mic if you feel better to talk. Now it's time to answer your questions, your doubt.
Yeah, can you hear me?
Yeah, sure.
Yes. Hi, sorry, yeah, this is Chris. I was trying to unmute myself before. What I was trying to understand is obviously it goes from Rhino into Revit. But if we're up to update walls, locations and things like that, does that easily go back into land design or?
Well, then you need another definition that references those walls in Revit, deconstructs them, and generates new walls in land design.
Okay.
And
no problem.
We can also produce those definitions too, no, Francis?
Yeah,
the
but
same place.
actually, right now, this is not really prepared because there is no wall element in Grasshopper right now. Okay, we're working on that. So probably you would import that wall as a poly surface, okay, or as a direct shape. So you would be able to import that geometry, that is a wall in Revit, into Rhino, but it would not be a lands wall anymore because there is missing this object as a component in landsdesign. But this is something that we will develop in future versions.
Okay, great. Thank you.
Okay. We don't hear you if you are talking.
Oh, yeah. Thank you. Any other question? Well, actually, it's worth to mention that the Grasshopper definitions and the Grasshopper components of landsdesign has opened new features for those studios, those firms that are working with analytical issues. For example, nowadays you can do shadow analysis with landsdesign, of course, by using the Grasshopper. You can apply different climate analysis with landsdesign by using the Grasshopper. And so there are like advanced methodologies that are applying by using landsdesign and Grasshopper. So you are more than welcome as academics and as professionals to discover these new features as well. So, yeah. Yeah, this is a good example. Yeah.
Yeah, another example where we can just do some clash simulation of plants that are collisioning with volumes, and those that are intersecting with these volumes, they show up in red color. So that's just another example of stuff that we can do with landsdesign. Okay, and combined with the Grasshopper.
So does that work? So
Yes.
if I get a IFC for like underground services, and I bring that in, and I want to clash that if I've built a root system in for the trees, will it work the same way? Could we get that working?
Yeah, absolutely.
Because I mean, obviously the canopy of trees, I mean, it's important, but the root system is probably more important for the clash analysis. So yeah, I'd be interested to see how we could work that in, and especially with a lot of projects that we do, the Podium based. So being able to clash that with structural slabs would be fantastic.
Be aware that the 3D representation of lands don't have like a 3D roots. Okay.
Yeah, but I mean, there's root zoning. So normally with planting, I'll create a mass of like 3 different root zonings, depending on the age of the tree.
All right.
So that we can clash against them. So we'll have a critical zoning, which you can't go in. Another zoning, which is like done on a individual basis, like acceptance. And then the next zoning, which is the ideal zoning, to minimize the effect on the plants.
All right. Yeah, well, take into account that you can reference all the plants, deconstruct the species, okay, and well, that way you can filter then that's not the proper component, but that way you can filter plants, okay, from their characteristics. So those that maybe have a specific characteristics for the roots or any other detail can be filtered, and then you can do stuff with this selection plants.
Fantastic. The other thing was I wanted to the other thing I wanted to ask was around your shade calculations. So
Mhm.
for me, so I work mainly in the UAE, in the Middle East, where Estadama reporting happens on most of our landscape projects, where we've got the primary and secondary path routes, and we need to calculate the shade on those paths. So when you calculate shading, can you isolate a certain route of like a 1.5 width path? So you can calculate how much shading is along that path. Is that possible?
This is only possible. I mean, with Grasshopper as well. And if you build your own definition that, for example, in this case, I'm gonna reference some plants, and I'm gonna set these plants. Okay, I cannot select them. I don't know why. Maybe we'll select that in advance and do now the right click. I know, because I need to do multiple assignment. Okay, I can use these plants, and now I can maybe have here a boundary. Could be a path, of course. You could generate a boundary out of a path. And now with this definition, we can just well, this is the boundary curve, and let me see what's going on here. But it's not working right now. I don't know why not. Looks like this is not
Baked, yeah.
baked. Well, anyway, you can also create, the areas of the plants, of the shaded areas based on a selection of plants and a boundary, and you get a total shaded area. I should revise why it's not working with this example, but the idea is that with Grasshopper you can do that of course.
Okay, no problem. Thank you.
Any other question? Okay. So we will have recording soon. I will send you.
I think I know why
the link.
it's not working. I should select the conceptual shape. And now, that definition only works with conceptual, representation of plants. And now we can see, these shadows here projected on that area, so we can calculate the shaded area based on this plant species.
Well, actually, the conceptual shape maintains the same diameter of the plant, so it's quite enough for, I think, for calculating the shadow. No.
Yeah. For the conceptual mass, it'll be fine. They're set in the Estadama report. They're all set for age of plants anyway, so that's fine.
Good.
Yeah, here it is, all the shaded area based, of course, on the conceptual shape. All right. So do you have any other questions?
Thank you very much, everyone.
Yeah. If you don't have.
Thank you, Francis.
I appreciate your assistance in this workshop. I hope you have enjoyed. And well, keep in mind that you have our contact here under the landsdesign website. You have also Elham's email. So feel free to share your feedback, your ideas, your questions at any time. We'll be happy to help you. Also, you can find some learning resources on the website. They are useful eventually. And here you can find our support email.
Thank you. Have a nice day and have a nice afternoon wherever you are.
Yeah, thank you so much for your presentation and stuff, sir.
You enjoy the rest of conference.
Yeah, thank you very much. Thank you.
Thank you very much. Bye-bye.
Bye.
Bye.